Hey everyone, before we look at the other two approximations, let's look at continuity correction. When do we use continuity correction? When we are converting a discrete distribution into a continuous distribution. I have a few exercises here. I'm going to show you where and when to apply continuity correction. Let's start with the first example. The first probability we have, probability of x lies between 5 and 8 inclusive. So we're going to draw a number line and then we're going to locate the 5 and then the 8. Next, we're going to minus 0.5, which is 4.5, and then we're going to add 0.5, which is 5.5. We are going to do the same thing for 8. So we have 7.5 and then 8.5. From this probability, we can see that 5 and 8 are included, which means that the new interval would be between 4.5 and 8.5, because when we take 4.5 and 8.5, we can see that the 5 and the 8 are included, because if we take 5.5 and 7.5, you can see that 5 and 8 will not be included. We have 5, 8 included, which means the new probability after continuity correction will be probability of x lies between 4.5 and 8.5. So there we have it, the continuity correction. Next one. Here we have 5, 8. Minus 0.5, we have 4.5, 5.5. Here 7.5 and then 8.5. We can see that 5 is not included. Therefore, we're going to take 5.5. 8 is included, which means we're going to take 8.5. The new interval, you can see that 5 is not included, but 8 is included. So our new probability will be probability of x lies between 5.5 and 8.5. Third one, we have 5 and then 8. 4.5, 5.5, 7.5, 8.5. 5 is included, 8 is not included. So we're going to take 4.5 where we can have 5 in the new interval, but 7.5 where 8 is not included. So after continuity correction, we have the probability of x lies between 4.5 and 7.5. Here 5 is not included, 8 is not included. So we're going to take 5.5 to 7.5. So after continuity correction, we're going to have the probability that x lies between 5.5 and 7.5. Next probability. Here we have the probability of x is less than 4. So we have 4 minus 0.5, we have 3.5, plus 0.5, we have 4.5. It says less than 4 where 4 is not included. So the new probability will be after continuity correction. We have the probability of x is less than 3.5. Next we have x is less or equal to 3.5, which means that the 4 is included. So here we're going to have probability of x less than 4.5. Here we have x greater than 4. Greater than 4, which means 4 is not included. Performing a continuity correction gives us the probability of x greater than 4.5. Here we have x greater or equal to 4. Greater or equal to 4 where 4 is included. So performing a continuity correction, we're going to have x greater than 3.5. 5. We have the probability that x is equal to 9. So 9. Here we do not have any inequality sign. So whenever you have the equal to sign and you need to perform a continuity correction, you simply take 9 minus 0.5, which is 8.5, 9 plus 0.5, which is 9.5. You simply take the probability of x lies between 8.5 and 9.5. So we do have the 9 in this interval. Next is greater than 0. So 0, we have negative 0.5 and 0.5. Performing continuity correction, where here 0 should be included. So we're going to have what? The probability of x is greater than negative 0.5. Here we have x equals 0. So directly we're going to have probability of x lies between negative 0.5 and 0.5. Last one, we have x is greater than 0, where 0 is not included. So performing a continuity correction, we have x is greater than 0.5. So this is how we perform a continuity correction. Next, we're going to use continuity correction in our approximations, where we're converting from discrete to continuous.